Flack math! Give me some math and I'll give you some flack. Flack math!
We are graphing a circle that's not in the center, and we are applying a dilation. So if you're just dilating a circle that's in the center, you just multiply or divide the radius by the scale factor. So a scale factor of 2, if the radius here is 7, then the radius is going to be, the new radius is going to be 14. Okay, so the equation would be x squared plus y squared equals 14 squared, which is 196. Okay, so if it's not in the center, and this is the tricky one, you're still doing the same dilation. So this time the scale factor is 1/3, so you're multiplying by 1/3. So 9 times 1/3 is 3. Actually, no. So the radius is 3 because the equation is 9. Remember, the equation is radius squared. So if radius squared is 9, that means the radius is 3. So dilating the radius by 1/3 will change it to 1. Okay, but then you have to do the same thing to the center. So 1/3 of 9 is 3. 1/3 of -6 is -2. Okay, I think that's it for 95. So let's move on to 96. These are quick lessons today, which is kind of nice because we're zooming. All right, so this is 96. Now we are going to, basically we're going to do more analyzing, but we're going to analyze the perimeter of a polygon and the area of a polygon when you change the dimensions a little bit. Okay, so let's just start with an example. A rectangle is half as tall as it is long. So if I were to draw a rectangle here, then this would be x, this would be 0.5x. You see how this is half as tall as it is long. Okay, so let the length of the rectangle be x, that's what we just said, and half of that would be 0.5x. So when you calculate the perimeter, you just combine like terms here. So x plus another x is 3x. Okay, all right, now here's what happens. What happens when the height is reduced to 1/2 of its original height? Okay, so 1/2 of its original height is now 0.25x, and it will be half of, or 2.25x. The length of the rectangle doesn't change. Find the perimeter. So the perimeter is still x plus x, but now it's 0.25x plus 0.25x. Combined like terms, 2x plus another 0.5x is 2.5x. Okay, so all you're doing is just plugging in and combining like terms. So now they want to compare the original to the original perimeter to the new perimeter. So how does 3 compare to 0.25x, or not 2.5x, sorry? Well, 2.5 is kind of a dumb ratio, so let's just double it. So now we get 6 to 5. So it's a 6 to 5 ratio. All right, let's see if that's what we got. So therefore the new perimeter to the original. So they just said it backwards. Instead of 6 to 5, they said 5 to 6, because it's all about how you say it. So the new to the original would be 5 to 6, but the original to the new would be 6 to 5. Okay, so it's also retrospective, is that the right word? To how you say it. So it's relative to how you mention it. Okay, so let's look at area. So triangle ABC, that the height is, okay, so the base is the same as the height. Okay, so this is this is not what that looks like. So maybe it's, actually there's a diagram. So see how the height and the base are the same. So if this is length y, the height is length y. Okay, well, how do you find the area of that? Well, area equals 1/2 BH, right? But B and H are the same. So it's A equals 1/2 YY, right? So 1/2 Y squared is our area. Okay, so here's the transformation. So the area of the altered triangle. So what is the ratio of the new triangle's area to the original? So if the base is dilated by a factor of 2, So now the new triangle is going to be A equals 1/2 2y times y, right? Okay. Well, this is just 1/2 times 2 times y times y. This is still y squared, but this 1/2 and 2 cancel out. So A equals y squared. Well, how does 2y squared compare, or 1/2 y squared compare to y squared? Well, let's see if we can make a ratio. So we're trying to find the ratio of the new triangle area to the original. Okay, so here's the new triangle area, and here's the original. Okay, so if we simplify this a little bit, we could cancel the y squareds, and we have 1 over 1/2. Well, let's double this because we don't like fractions and fractions. So if we double it, we just have a 2-to-1 ratio. Okay, you see how we're getting these? Does it make sense? Okay. I see Kate nodding her head. Good job. All right, a parallelogram's base is twice as long as its height. Okay, so another thing like this here at the height. So if this is x, this would be 2x. All right, if the length of the base is doubled, so now it becomes 2x. What is the ratio of the new parallelograms to the original parallelograms area? Well, area equals just base times height. So in the original, it's just x times 2x. Oh, I'm doing this wrong. The base is twice. No, this is 2x down here. It's the same thing, but this is just x, and then this is 2x. So it's still x times 2x. So this is just 2x squared. All right. But then we've got the half. If the length of the base is doubled and the height is cut in half. Okay. So now the new area is going to be, this is doubled. So this is 4x times 0.5x. All right. Well, that's easy. 0.5 times 4 is 2. So that's 2x squared. Look at that ratio. It's the same. It's 1-to-1. So 2x squared over 2x squared. That cancels to 1-to-1 ratio. Okay. So all you're doing is trying to rewrite it with variables and then simplify that ratio as much as you can. Okay, a circle's radius is increased by a factor of 3. Find the ratio of the circle's new area and the circumference. Okay, so area is pi r squared. So that's the original, all right? But the new one is factor of 3. Factor is multiplication. So here's the old, here's the new. The new area is just pi times 3r squared, right? So the radius is now 3r. So that's just 9r squared. So this equals pi times 9r squared. Well, can you figure out what the ratio, what the difference is? Well, this is, if you put these on top of each other, so 9 pi r squared over pi r squared, it's just a 9-to-1 ratio. Okay. All right, and then the circumference. Okay, let's look at the circumference. Circumference equals pi times diameter. All right, or pi times 2r, or 2 pi r. All right, so if we increase the radius by a factor of 3, that means we're going to multiply the radius times 3. So this is the new one. Sorry, it's messy. 2 pi, and instead of r, it's 3r. Okay, so this would simplify to 6 pi r, and this is 2 pi r. So what's the difference? Well, 6 pi r, we can, over 2 pi r, these guys cancel, and this reduces to a 3-to-1 ratio. Does that feel all right? Okay. Guys, that was short and simple. That was easy. if you guys want to work on some problems and get your homework out of the way, that would be great. That way you can enjoy prom tonight and you don't have to worry about homework over the weekend. You can do that if you want, or if you want to sit quietly, you can do that as well. But let Mrs. Waite know how many you do, and I'll give you Flack Attack coupons for every 5 you do. Okay, any questions? All right, Kate, I'm trusting you're speaking for everybody.
Kate?
Yeah, you just said no.
Head nodding? Yeah.
You said no, and you say yes when I say, does this make sense? So I'm guessing if you guys have questions, you'll speak up. But
on behalf of everyone, my head
right.
nod.
Thank you. You're doing great.
Oh, you're great. Thank you. We all love you, Mr. Flack.
All right. Well, it's good to see you. Hopefully, we'll see you next week.
Black man, give me some math and I'll give you some flack.